Okay.
What, you're recording the lesson?
Yeah.
Hi, okay. So, I guess it's kind of good now, but let's pray first. Let's pray. Dear God, dear Heavenly Father, thank you for bringing us here today safe and sound, God. Thank you for helping us rest last night, God. And thank you for improving the health of Missy and Paul. And for anyone else that's been sick, God, I pray that you help them out and help improve their health, God, and they be at their best, God. And I pray for Aliana and the rest of the choir team that's traveling right now, that they may be in high spirits, God, and that they may perform to the best of their ability, that you may be glorified with their son. I pray all this in Jesus Christ's name. Amen. Okay. So, how you guys doing? Alive? Slightly more and more alive every day?
Right now, it's like a little stress-free. So we didn't have homework, but then it's kind of like.
But
and then we have Christmas.
You have a difficult week, and then you have 2 months of Christmas.
2 months.
30 days of Christmas or 2 weeks, yeah. Same thing.
It's 2 weeks?
Yeah.
2 weeks, but you have the weekend before and the weekend after. So it's like 18 days.
That's like close to a month.
Minus.
All right.
Pretty close.
Closer to.
So
Yes.
we have a midterm study guide that we're going to be working with today. Everyone has gotten one except for our young soldier of God here. You didn't get that? I didn't give that to you guys yesterday? I didn't give that to you guys? No, I know.
You gave it to us.
I thought I did give it to you.
You said look.
I don't even know what class I got this in.
I gave it to you. I gave it to you when I handed you back your homework and your review packet.
So many things. I'm gonna have to get a new binder too.
Okay, well, just look for it. We're going to be using it today. But, no? Don't have it?
You know, whole country.
Okay. The exam is going to be similar to our previous exams, but also different in the sense that it's obviously there are 34 points on this. I can't give you a free response question on 34 different points because we'd be here for 5 hours. We only have an hour and a half for the test, so there will be multiple choice, there will be fill in the blank, maybe some matching type of questions, things like that, that are very simple and straightforward, and there will be some free response as well. If you have, so you guys just don't have it, huh? Do you have it missing? Maybe?
What you just gave Brandon?
Yeah. You do have it?
Yes.
Okay.
I was just really unorganized right now.
It's alright. Don't worry about it. Okay. Just make sure you can share it with somebody and look it over right now if you can, because I'm going to make a few points.
On the Thursday.
Christmas. Alright. So we're going to be much heavier on the second half of this review sheet than on the first half of the review sheet. So basically from
Maybe it's with you. No, I don't get right now. Huh? Maybe it's with yours.
yeah. So it's going to be heavier on like 21 and beyond. You can expect that I'm probably gonna go on more on the second half than the first half. That being said, we're gonna cover everything in as quick a way as possible.
34 questions or just 34 topics?
34 topics, not necessarily all of them will be covered.
How many questions?
It will be
Including your ABC questions.
Your A through Z
A
questions.
through G.
So do
Yes.
you believe in A through Z questions?
Do I believe
Oh,
in
it's only
G?
4 questions.
I believe that a lot of people have different ways of
What question
describing
take
the alphabet?
Christ, and I believe everyone has access to Christ, and that, like Chi, right? You asked me about Chi, right? So I believe everyone has access to Christ, and everyone experiences Christ in their own way, but many people have different religions and different forms of.
Like that's maybe.
Listen. So Chi, right? When people experience what they call like Chi energy, you guys have heard of it, maybe.
Yeah.
So
like,
there, right?
Is that
There's
it?
like there's different. There's I'm on video, so I have to be
But that's
careful.
like that's.
But
real.
what's
It's like
there's an energetic system inside of your body. This is all proven by science right now. They've had pictures of your what they call your aura. Have you guys ever heard
Yes.
of that?
Yes.
It's been scientifically shown that you have an energetic field around your body. It just makes sense. You have electricity flowing through all your nervous systems. If you have any understanding of the way electromagnetism works, anywhere that a current flows, there's an electromagnetic field, right? So if you have an electromagnetic field, right, and you're able to dictate how that energy flows in your body, you're able to then manipulate it potentially, okay? But that being said, there's tons of people out there that like okay, maybe if you're a Tibetan monk sitting on a mountain and you're like
Yeah.
practicing kung fu all the time, you're able to do some stuff with it. But there are also tons of people that are just like complete liars. For instance, I saw, and this will be the end of it, I saw this one video of this guy who was a Kung Fu Chi master, and he was like, look, I can defeat you with my Chi powers. And he had all of his students, and he would just like wave his hands at them, and they'd pass out.
Yeah.
Right, did you see that video? Right, and then the best part about it was then he was like, look, I'm Chi master, infinite energy, power. And he was like, all his disciples were like, oh my goodness, like they were passing out and stuff.
And then get to the guy.
No, and then I don't know, maybe yeah, but then what happened is like he was like, look, I must demonstrate, and he mixed martial arts fighter, just a guy who just uses his fists and his feet, right? He was like, okay, let's fight then, me and you. Like I'm mixed martial arts, you're Chi energy fighter, and like he's like, okay, and so they went to go fight each other, and the Chi guy's like, whah, whah, and the guy just like. He just knocked him out. Like he got really hurt. Like it was bad in the long run. I was like, oh my god, poor guy, because he was an old guy. But at the same time, it's like, all right, man, like you don't have Chi superpowers. So anyway, so that being said, it's like, and that's the thing with yoga too. And now I'll really stop. Like yoga, if you turn it into a religion, then yoga is like a really, like it's Hinduism, and it's multiple deities, and they believe that there are many gods and all these kinds of things, and it's kind of a really dangerous path to walk on. But if you look at it as something that's like, this is a really good thing for your cardiovascular system and your lymphatic system and your nervous system, then
What's the difference between
It's like
yoga
working out,
and
basically.
Pilates? No, yoga's hardcore.
Yeah,
I sweat.
like what-
the difference between yoga and Pilates is like, I don't know necessarily so much about Pilates, but yoga is based off of basically a scientific practice that's been passed down for like thousands of years. Like these really old dudes in India like discovered all these ways of stretching the body that now has been like scientifically tested, like
It's like working out. Like, it's like
What?
working out in a way because like it just helps your body. Like,
right.
I feel like
But
you
it's
just
just-
sweat.
The only difficulty
It's
is
You're
like if
It's
you
so
were to
hard.
do yoga, just be careful where you go, because a lot of people do incorporate like Hindu type of methodologies, and I don't ascribe to that. But there is Christian yoga, so I'm thinking of maybe starting a class.
You should be, yeah, let's make a yoga class.
let's do it. First 5 What's minutes like your class, what's dedicate your to you. most First like person. intricate like
First,
position
That I
type?
can do.
Yes, the hardest one.
can you show us one right? Can you give us 7 yoga poses?
Oh no. I have a suit on, it would be very challenging. Okay, alright. Now that we've covered all of those bases,
Right?
okay, so let's begin our process of reviewing for our exam, shall we?
Yes.
Okay. First point slope form. What's point slope form? Y
minus
y1 equals mx2 minus x1.
Not x2 and y2, just y. These are the variables, and this is the point. So you have to find the slope by getting, I give you 2 points, you find the slope, and you very simply just put into this form. Slope intercept form, y equals mx
plus
plus
b.
b. Okay, very good. Parallel perpendicular lines. Parallel lines have what slope? Same slope. Perpendicular have
Opposite.
wait.
Reciprocal.
Reciprocal.
Negative reciprocal. Parallel lines have same slope. Perpendicular lines have negative reciprocal slope, right? So if my slope is 3, the perpendicular line will be
Negative 1/3.
right. If it's 2/5, it'll be
Negative 5/2.
right. And if it's 1/3, it will be
Negative 3.
good. Awesome. Very nicely done. All right.
Aw.
I apologize. It was 3 and negative 1/3. I kind of really have to know 1/3 and negative 3. All right. Functions. How do I know if something is a function?
If it passes
the
one vertical
lines.
line test.
The what kind of line?
Vertical.
So vertical line test. Yes. Also, if I were to give you something like this, y squared equals x, is this a function?
No.
it's not.
No, because that would end up being y equals plus or minus radical x, right? What about if I give you y to the 3rd equals x?
Yes.
That is a function. Very good. Okay, the way that you can tell is if I've got an even exponent on my y, then it's not going to be a function. Right?
So we don't actually need to work it out.
No. On these type of questions, basically 1 through like 10, it would all be for sure multiple choice. Okay? Domain and range is the next point. Domain and range. Domain and range. So this will be something along the lines of this. I've got something that looks like this, then something that looks like this, then something that looks like this.
A piecewise function.
A piecewise function. Exactly. All right, and I need to figure out the domain and range. So to find the domain, I start at the left side. I take my hand or a pencil or my finger, and I start at the left. And I say, does my function exist here?
Yes.
Yeah, so it starts at negative infinity, then goes over to where?
That.
Let's say that's 4.
4.
So it's a negative 4, right? Is that inclusive or exclusive?
Inclusive.
Inclusive, right?
Union.
And then it goes over, so I union to where?
2.
To 2, but is it inclusive or exclusive?
Exclusive.
Exclusive, very good.
Why is it inclusive?
Because it's got a dot or a hole right here.
Inclusive is
Filled in.
filled in.
Filled in, exactly. And then I go over and I say, oh, but it stops here at 0, but look, it picks up again. So what would that be from 2 to, or negative 2 to?
Infinity.
Infinity, very good. All right, now my range, I start at the bottom. And do I say, does my function exist here?
No.
So it's not negative infinity, it starts at where? Let's say that's negative 2, so it's at negative 2.
Negative 2.
What is that?
Exclusive.
Exclusive, good. Now I go up, oh wait, but it stops, but it continues right here, so it just
Infinity.
continues to infinity. That makes sense, everybody?
Wait. The negative 2 is inclusive?
This is exclusive.
Infinity is exclusive.
Oh, okay.
Right? Okay.
So if it's a whole,
It's exclusive.
yeah, so it's the regular classes.
All right.
Are we gonna have to graph the piecewise function, or you just
No, I'm going to give you this graph, and I'm not even going to ask you to solve for it. I'm going to just give you, well, I'm going to ask you to solve in a way, but I'm going to give you multiple choice. I'm going to say, here, A through D, which one is the correct domain and range? Right? Okay. Relative and absolute extrema. If I give you something like this, right, here's my function. What are these 2 points? So relative max, relative min, and this would be my absolute min, and good. That's the concept. And then it would just be like, you'd say A through D, relative min here, relative max here. You just have to figure out which one is correct. Okay?
On the test, like on the first test that we took, you said that it wasn't like exact. You didn't answer it like that. So how would we find out?
It's going to be different this time because in that time I gave you the function, like I gave you f of x is equal to x squared or something like that. And then it was clear that the x was at -1 and this was at 1, and then you had to plug into this function to find the point. This time it's just going to be obvious where these points are. Okay? Good question. All right. Even and odd symmetry. Even and odd symmetry. Even symmetry has what kind of exponents? What kind of exponents?
Even.
Even exponents. Odd symmetry has what kind of exponents? Odd exponents. Very good. Even symmetry is symmetric about what?
The y-axis.
Y-axis symmetry. And odd symmetry is?
Origin.
Origin. Very good. If I want to write this in a very specific way, I would say f of what? Negative x equals f of x for even symmetry, and for odd symmetry, f of negative x equals what? Negative f of x. So look at this graphically. Even symmetry just flips about the y-axis, right? So f of x equals f of negative x, right? And this flips about, if I start here, it flips about the x-axis first, and then it flips about the y-axis. So f of negative x is the negative of f of x.
Did you say it flips about the y equals x?
Yeah. Wait, hold on.
No.
No. No. It's origin symmetry. All right?
So what kind of question?
I'd give you different functions and then say which of these are symmetric, or write down the symmetry, even, odd, or none.
What would be none?
What was that? None would be like.
Well, I know the graph, but like the equation.
It just wouldn't be an equation.
Oh, so you're gonna put that like the graphs in the same. You can do like the line test, right?
Right, but I could also give you functions, right? I have even and odd. No, not necessarily the line test wouldn't be for symmetry.
The horizontal line.
But even, what was that?
The horizontal line test.
That's for inverses you're thinking about. But even symmetry has to have all even exponents. So if I say x to the fourth plus x squared plus x, to the 0 or like 1, right? That's an even symmetric function, right? An odd symmetric function would be x to the fifth plus x to the third plus x, right? And neither would be like x to the sixth plus x to the third plus 2, because it's got even and odd. See? Good?
Like would it be like x to the
So
0?
you're gonna give us one and say prove that it's this.
I would
Or
give
is
you
it this
I
and
would
prove it?
I would give you graphs, or I'd give you functions, or potentially both. And I'd say list the symmetry. And you'd have a space next to it and you'd say, oh, that's odd, that's even, that's none. That's even, that's odd, that's none.
Okay.
Just like that. No, you wouldn't. I'm not going to ask you necessarily to prove it on this one. Okay? just because I believe you can, and it takes enough time that it's kind of silly. All right. Though I do say on number 8 that I asked you to prove it, but you should know how to do that. Anyway. What was that?
You do 8.
Proving even odd symmetry? No. But to go over it, class, if I have f of x, if I want to prove even odd symmetry, say I have x to the third plus x to the first, right? I have to prove this is odd, or let's just say x to the third to make it easy, right? Well, I plug in f of negative x equals negative x to the third, which equals negative x to the third, which is negative f of x. So f of negative x equals negative f of x, so that's odd, right? If I have f of x equals x squared, all I have to do is, once again, plug in f of negative x. So I plug negative x squared, which equals x squared, which equals f of x. Therefore, it's even symmetry. That's how you prove it, just by plugging it in like that. Okay. The next thing is composite functions. Does anyone remember what composite functions is? Oh, you're right, it is function transformation. Thank you. You done copying this down? Function transformation. So, this one is going to be a very simple one, like you've been tested on. And by the way, your Thanksgiving review packet is really helpful.
Did you get that back to us or not?
Yeah.
I'm just,
Yesterday, you were just.
yeah.
Okay, so it's going to be something like this, and then you have to figure out which function matches with which one, right? So you have to remember the horizontal shift and vertical shift and the stretches, right? Okay, so for instance, if I have x squared, right, and then I say x squared plus 2, that's a what? That's a vertical shift. If I say x minus 2 squared, that's what?
Then it's shift to the right.
Horizontal shift to the right, right? If I say x minus 2 squared times 2, that's what? Shift to the right and a vertical stretch.
So will that be narrower?
It would be taller, right?
Yeah.
So shift to the right and stretch it up like that. Yes, and narrower basically. All right.
And then 1/2 is wider.
1/2 would be wide. Okay. All right. And once again, your Thanksgiving review packet and your test, you basically have the same kind of questions on there. Okay. Now composite functions.
This thing fell.
You're coming in 5th hour, right?
Yes.
Remember, it's on you. Gotta remember to come. I can't track you down. I don't know where you might be. Everyone remind him to come to my room in 5th hour. Are you in art class with him?
Yes.
So if you see him, kick him out. All right. Composite functions. This is f of g of x, right? Or in other words, f of g of x, right? Okay? If I have f of x equals x squared plus 2, and g of x equals 2x minus 3, right? If I want f of g of x, everywhere I see an x in f of x, I just plug in g of x. So this would be 2x minus 3 squared plus 2, right? And then I could simplify, right? And then if I had g of f of x, that equals, everywhere I see an x here, I plug in f of x. So it would be 2 times x squared plus 2. Very good. Alright, so those are composite functions. Which brings us to, what was that?
You have to solve for it at all? Or you-
No, I would just say, what's f of g of x?
Okay.
Right?
I think that one was the best one.
That was like,
The faculty one was the best one.
They should have done one for Coach D.
I love Miss PDs.
oh yeah, that was good too.
Jen's 10 different
That was
pages.
funny. 10 different payments. That's so true. They have a payment like every week. There's like something to be paid.
The Andrew room.
Because of just like
Everything.
Trips,
fundraisers and trips.
senior years, sports.
Good. Okay. Next, inverse functions. Inverse function. If I say, first off, what's the test to see if something has an inverse?
Plug in negative x.
It's the what test? Ivan?
Horizontal line
line.
test.
Horizontal line test, right? So in order for something to have an inverse, it has to pass the horizontal line test and the vertical line test. Obviously, if it doesn't pass the vertical line test, it's not a function, right? So it's obviously it can't have an inverse, right? But also it has to pass the horizontal line test. That passed the vertical, but not the horizontal, right? So it has to be something more like this, right? Which passes the vertical line test and the horizontal line test, right? So that's one thing, to test if something has an inverse or not.
They're gonna give us something like that.
You never know.
Okay. So that's that. But then also what is? If I have f of x equals, let's say, 2x plus 3. Make it simple. How do I find the inverse?
Make f of x equal y. Change x and y. Solve for x.
Solve for y. So I have y equals 2x plus 3. I swap it, so it's x equals 2y plus 3. Then I solve for y. Subtract 3 from both sides. X minus 3 equals 2y. Divide by 2. And I get y equals x minus 3 over 2. Or f inverse of x equals x minus 3 over 2. Now, how do I prove that I have in fact found the inverse?
You plug in.
f of the inverse of f of x equals x.
Very good. F of f inverse of x equals x. And also f inverse of
f of x equals x.
x, right? So those are composite functions right there, right? So I have f of x equals 2x plus 3, and f inverse is x minus 3 over 2. So if I do f of f inverse of x, everywhere I see an x, I plug in x minus 3 over 2. Right? So this is
2 times.
f of f inverse, very good, of x equals 2 times
x minus 3 over
2 plus 3. 2's cancel out, then this minus 3 cancels out this plus 3, and it just equals x. Good. Then I try the other one, f inverse of f of x equals, now everywhere I see an x here, I plug in that, right?
Yeah.
So I plug in 2x plus 3 minus 3 over 2. Those cancel out, 2 cancels out, left with x.
Not 2.
Not 2. Alright. Good. Aliana, you following?
Yes.
I think so.
For a second, I was like, what?
We're FaceTiming, right? That'd be cool. Was it with your class that I suggested that? Like if you guys were ever absent, we'd set up like a, it wasn't with this class? That'd be cool, right? If you were ever absent, you could just, I did that with Emily in my Algebra 2 class. Plays guitar during the
Yeah, she did that during
she FaceTimed and took notes while we were reviewing for our test or something. It was pretty good actually. Anyhow. Soon enough, all classrooms will be fully digital. And you guys won't ever have to leave your bedrooms.
That's what they have for the virtual.
Right. It's kind of weird though.
How cool would it be to have a board? She always teaches the kids moderation instead of writing on the board.
That's a cool idea.
So it's my first one.
Okay, inverse functions, proving an inverse good, completing the square.
How is like this?
Good. Completing the square. Okay, if I have f of x equals x squared plus 6x plus 9. How do I complete the square?
Well, you divide 6 by 2
And square it.
and then square it.
And then add it to.
So
add it.
step by step, I rewrite the function until this point.
Yes,
Leave a space.
Plus 9 because that's what it is.
6 over 2 squared, right? 6 over 2 is 3
9.
squared.
Wait,
So
Plus
add
9.
9.
Wait, couldn't it
But
just
then-
be 9?
Plus
Or why would
Nine.
you?
Plus 9 minus 9.
Why would you
And
do
then
that
the
in the
rest
first
is
place?
that.
then?
What was that?
Why did you complete the square in the first place?
Oh yeah, it is a
That's
square.
what
It is a square. Okay. Because I did that by accident. Fine. Let's make this 10. All right.
Much better.
You're welcome. So
now
now
you have
I put this in parentheses, right?
You get x plus 3
How do I know it's 3?
because 6 divided by 2 is 3.
6 divided by 2 is 3. Good. Squared plus
1.
1. Good.
so now your point
I've completed the
And
square.
then your vertex
Now, okay, all right.
is
negative 3, 1.
This is also known as, this is what? What would I call this type of equation?
Standard form.
Well, hold on. This is a, what?
That's a s-
Oh.
That's a parabola.
What shape will that be?
It's a parabola.
A parabola. So,
Is it a circle?
it's okay.
So,
It's kind of like a circle, just less
Almost.
curved. All right.
That's a standard form of a parabola.
This is the standard form of a parabola. By completing the square for a parabola, we get the standard form of a parabola. Okay, the standard form of a parabola is what?
X plus k
minus h
X minus
squared. X minus h squared plus
Plus
k. Right? Where h and k are
your vertex.
the vertex of the parabola. Right? So the vertex here would be what?
Negative 3, 9.
Negative 3, 1. All right. Got it?
Oh, yeah.
or, yeah.
That's how we find the vertex of a parabola. Okay?
You're coming in.
How do we use this to find the zeros of the parabola? Not
You do
plug in
something
0.
else. You do
I do x plus
X.
3 squared plus 1. And I want to find the zero, so what do
Equals
I say equals 0, right? That's not very nice.
So isn't there something that you do?
What?
There's like a second problem.
Yeah, that's what I'm doing. Okay, so I said this
But
equal
then
to
you
0.
add to the other side.
I bring this over, I subtract 1, right?
Wait, this is 16, right?
No, like the problem that you add.
This is
say, like, you
16,
add 9
yeah.
to the other side. What is that?
That's if plus time was on the other side.
Oh, you said it equal to 0 or something.
If I wanted to use completing the square to find the zeros in the function, then I would immediately set it to 0 rather than
Instead of doing that.
exactly.
So it's 1.
So right. So if class, if I had set this equal to 0 at first,
Okay.
if I'd set this equal to 0 at first, I could have, when I added 9 here, I would have added 9 to the other side. But then I would have subtracted 10, and I would have still ended up with what I'm going to end up with now, which is -1. Right? So now there are no real zeros of this, right?
Because you can't take the square root of a negative number.
Right, but we learned imaginary numbers, didn't we?
I know, but
Oh,
that's
no,
not
we're not
the
going
same.
to
We don't have an imaginary zero.
Okay, I take the square root of both sides. Relax, imaginary numbers are just imaginary. They can't hurt you.
X plus 3.
X plus 3 equals what?
I.
Right, plus or minus I, right?
Yes.
Then I subtract 3 from both sides, and I get x equals -3 plus or minus I. Okay? What is apoptosis?
Yes.
What is it?
Cell death. Mass cell death.
Like,
Oh,
that's
I remember that. From what was that?
Biology.
So to find the 0, you always set it to 0.
What was that?
To find the zeros, you always set it equal to 0?
Yeah.
Okay.
To find the zeros of a function, right? Now, class, this parabola, is it going to be looking like this or looking like this?
First one.
First one, right?
Leads.
Okay. This top one, how do I know it's like this?
Because it's positive.
It's positive, so it goes up on both sides. How do I know it goes up on both sides? I know it's a parabola, but how do I know it has the same
End
type of
behavior.
end behavior?
Even.
Even, right? So it's positive end behavior. So now the fact that it doesn't have any real zeros means what?
That it's above the.
Right. It's like this, right? It's above the x-axis. Does that make sense? Right? Okay. Very good.
If you say that end behavior should be, it's just.
When you can you
We're going to get into end behavior in a second. Actually, I want to cover, I realize I skipped one thing.
standard form.
Standard form of a complex number is a plus bi. Okay? Now,
So that.
let's go deeper into this.
Mr. Minier, do you know what that says?
Yeah.
Did you read what it says?
Commit full body apoptosis. Yeah, that's why I was so traumatized by the fact that it means cell death. I don't know why anyone would want to do that.
You should.
Who wrote that?
I have no idea. But maybe I should reach out to them.
It's a joke.
X
No,
plus
I'm just kidding.
X plus 3 equals X plus 3 equals No.
So sweet. Okay. All right. If I have 2 plus 3i over 3 minus 4i,
Multiply by the conjugate.
the conjugate of what?
3 plus 4i over 3 plus 4i.
There you go. 3 plus 4i
What is
over
this called again?
4i. Getting standard form of a complex number.
Okay. So you get
So you get 6
Okay.
6
plus 8.
plus
Let's
8.
remember, if I have a minus b times a plus b,
You
I get
A
what?
squared plus B squared.
A squared
minus B
minus b squared. So on the
Never
bottom,
trust that.
I get what? 3 squared,
which is 9.
9.
And 16.
minus
16.
Let's just keep it like this for now, 4i squared, just for now. Okay? All right? Then here I just FOIL it out, right? So it would be 2 times 3 is 6, plus 8i, plus 9i,
Plus 12I squared.
plus 12i squared. Now, I equals the square root of -1. What's I squared?
-1.
-1. What's I to the third?
1.
negative I. Right? I just multiplied by another I, right? What's I to the fourth?
1.
1. Because it'd be I times I is negative 1 times 1, right? Or you can think of I squared, which is negative 1 squared. Okay, good. Okay, so I have 6 plus 8i plus 9i is 17i, plus 12i squared. I squared is
Negative 1, so minus 12.
minus 12. Then I have 9 minus 4 squared is 16. I squared is negative 1, so it's plus 16, right? And I end up with 6 minus 12 is negative 6 plus 17i, all over 9 plus 16 is 25. Okay, and to get that fully standard form, I just break up the fraction. Negative 6 over 25 plus 7 over 25. 17 over, thank you. 17 over 25i. And you are done. Did everyone follow that?
Lost.
Where did I lose you?
I was really copying down.
Okay, did you get 6 plus 17i minus 12? You see where that came from?
Yeah. Wait.
Sir,
Yes.
on the bottom,
Mm-hmm.
never mind.
Do you understand?
Yeah, I understand.
Because what happens is I have 9 minus 4i squared, which equals 9 minus 4 squared times I squared, which equals 9 minus 16 times negative 1. Because I squared is negative 1, which equals 9 plus 16, which is 25. Very good. Almost halfway done with our review already.
We're so smart.
I know. I was so happy when I was writing all these reviews for my class. I was like, wow, we learned a lot.
The hardest thing was
Did we reach your
our
syllabus?
previous test.
What was that?
Oh
Not
yeah,
the one
that,
that we just took, but the cosine,
Approving the
Yeah, that-
cosine.
oh
all that
no.
stuff. That's I feel
We
like
have
that's
like
even worse.
one problem on that.
Yeah, combine those two
And we have
questions
to
into
learn-
one.
We have to
Like
learn
all of those
properties,
things.
don't we?
Yeah.
All those.
You're only going to be expected to remember the same ones that I expected you to remember on the previous exam.
Are you giving us the ones you gave us?
And I'm giving you the ones that I gave you. You'll be okay. The spirits in the room just went, it's okay. Come on.
That lesson.
Oh, goodness gracious. My, oh my.
What did you say?
Our aura.
Okay.
That was like the class.
All right. End behavior.
I didn't get that one.
End behavior of a function. Okay? So if I say to you the degree of a function, what does that mean?
The exponent.
The highest exponent. So if it's x cubed plus x squared plus x plus 1, what's the degree of that function? 3. If I change that to 4, it's, and if I change that to 27, it's,
27.
right, good. Okay, if I say that 3, 5, 9, 3x to the 27 plus 5x squared plus 9x plus 1, what's the leading coefficient? 3. The leading coefficient is the number in front of the highest exponent. Got it? Okay, so for end behavior of a function, if I say to you the leading coefficient, this is a table here if you want to copy it down, degree, or degree on the other side. Leading coefficient, left, right. Okay? Okay. So if the degree is even, that means I've got x to the 4th, x to the 6th, x to the 8th. If it's odd, it's x to the 3rd, x to the 1st, x to the 27th, right? If the leading coefficient is positive, negative, okay? If the leading coefficient is positive, then the end behavior as I'm going to the right for the even and the odd is both up. If it's negative to the right, it's both down, okay? For the even functions, the left and the right have the what? Same end behavior, right? So for a positive leading coefficient, it's up to the left, and a negative leading coefficient, it's down to the left, right? Okay? For odd,
It's opposite.
they have opposite. So if it's a positive leading coefficient, it's down to the left, and negative leading coefficient, it's up to the left. Right? So what this would look like is, an even function could look something like this, right? Would this be even or odd? Odd. What? Odd. What about this? Even. And this? Odd. And the leading coefficient here is? For this one?
Positive.
Positive. And for this one it's?
Negative.
And this one it's?
Positive.
And this one?
Positive.
Understand? To figure out the leading coefficient, you just look at what it does to the right. Up, positive, down, negative, up, positive. Got it? All right, good job, class. All right, what I suggest is that you look at your review sheet. We just finished off on 18, so look at 19 and beyond and see what you could potentially need help with. So that when we come in tomorrow, we can have a guided review session.
Same thing.
What was that? Yeah, we'll be doing a review. Oh, everybody say goodbye to Aliana.
Bye, Aliana.
Bye-bye. Everyone loves you. Bye.